Okay, so I'm so sorry that we didn't get that done in one video, but this is actually a good thing because I can do a couple more examples with you. So the last page of those notes is about the difference between a sequence and a series, and there's actually something new that you may have never seen in your little math life before, so I'm so excited to be able to show it to you. But that is what a series is called, okay? So let's go start to fill this in, and then we'll do the really cool fun stuff. So listen, a series, okay? So a sequence, remember, is like the different numbers, right? So like 1, 2, 3, 4, right? Okay, that's a sequence. A series is the sum of a sequence, okay? It's the sum of a sequence. And so basically you're going to add it together. So you hear a lot about sequences and series together because they are really related. I mean, obviously, if you're going to add up all the numbers in a sequence, right, you know, that's why we kind of talk about them together. But maybe you need to know a cumulative total of some different numbers that you have, okay? So here is a sequence, 1, 2, 3, 4. This is a finite sequence, right? The series would be adding all of those together. If we add all of those together, we get a 10, okay? What about an infinite series or an infinite sequence, though? What happens if you have an infinite sequence? How do you add that together? You know what I mean? How do you do that? And so with this one, because this goes on forever and it's actually being multiplied by 3, those numbers are going to get really flippin' big, right? So if you're going to add this sequence together, you're going to get infinity, okay? It's going to add to infinity, and we actually call it a convergence, not a divergence like the movie Divergent, right? But a convergence. We say it converges to infinity. This one is a little bit more challenging to see and to think about, but let's say you had to add a half, a fourth, right, an eighth. And so if you were actually in the building, I would make you do this, okay? But let's say you have this one Post-it note, right, this one little piece of paper, and I'm going to go ahead and rip it in half, okay? So I'm going to take my half. It's really not half, but close enough. You get the idea. So I'm going to take this half, okay, and I'm going to add to it a fourth. So I'm going to add this piece to it, okay? And then I'm going to add an eighth. So I'm going to add this little piece to it. I can get them in my fingers right. And then I'm going to add a 16th, okay? So when I go to add all of those pieces back together, what happens is that we say it converges to that one Post-it note, okay? And so this particular sequence, this particular sequence, 1/2, 1/4, 1/8, and 1/16, this actually converges and it adds to be a 1, okay? Sometimes you have a sequence of numbers and you want to just do a partial sum, okay? So a partial sum is just the sum of a specific number of terms, okay? It's just the sum of a specific number of terms. And we actually denote that, the annotation that we use, the like way we write it, okay, is with a capital S and then N, so S of N. So this S of 9 means to find the sum of the first 9 numbers, okay? This one, the S of 4, means to find the sum of the first 4 numbers. I actually want to do this one with you together because this one is probably the easiest one. But the sum of the first 4 numbers, 1, 2, 3, 4, are going to just be these numbers right here. And so that's what we're going to add together, okay? Just the 4, 7, 13, and 25. And that number is, let's see, 49 and 20, or I'm sorry, 29 and 20 makes 49. Okay, so that's a 49. The sum of the first 3 numbers, that one is also relatively easy. It's a little bit different with fractions, but still relatively easy. So let's see, 6 sixths, right, plus 3 sixths, plus 2 sixths, 9, makes 11 sixths, right? We do the fractions. Sometimes, though, you have to find the sum of a specified number and that the number of terms in the sequence isn't listed for you, so you have to figure them out. Okay, so like this one wants the sum of the first 9 numbers, and I only see 1, 2, 3, 4, 5 numbers. So I'm actually going to be adding the numbers 1, 2, 3, 4, all the way up to 9. Okay, and that is going to give me a 45. Okay, go ahead and see if you can figure out what number 3 is, but there's something so amazingly cool that I want to show you, and that is what is called summation notation. Okay, listen, mathematicians are lazy, right? We are lazy, and we try to find a way to take all of these ideas with numbers and shrink it and write it a little bit more efficiently so that we don't have to write it all out, right? We don't want to have to write everything out, okay? And so we use the sigma symbol to do that. Now, most of you have seen the sigma sign before. You just may not have done the math that goes with it. And so this is super exciting. Okay, I'm excited for you. Here's what we do, okay? This is what it looks like. This is what it means, okay? So you're going to see this thing right here, the sigma, okay, or the summation of 2n from 1 to 5. This is what all these pieces mean. Down here, okay, where it says n equals 1, this is going to be your first term. The first term number that you're going to find. So if n equals 1, you're finding the first term, okay? This number up here is the last term number that you're going to find, okay? So we're going to add up the first term, the second term, the third term, the fourth term, and the fifth term. So we start here, we end here, okay? The 2n is the formula. Okay, this is the specific formula that matches the sequence. Okay, and so here's what we're going to do. We're going to do a couple of examples, but I want to kind of show you what it means and what it looks like. So the first thing we're going to do is actually this one and see what it means. All right, so if I'm going to find the sum, and I'm going to do this summation notation, here's what we're going to do. We're going to go plug in a 1 because I'm starting with the first term, so I'm going to put in a 1. So 2 times 1 is 2. I always break my pencils. Okay, let's go do a 2, right? So the second term, 2 times 2 is 4. The third term, 2 times 3 is 6. The fourth term is going to be 8. And the fifth term is going to be 10. So I'm adding up the first through fifth terms. And here's the pattern, the formula that I use to get the actual term values. Okay, so now I'm just going to go add it up. When I add it up, let's see, I get 12, 24, plus 6 makes 30. Okay. All right, let's go do it again. Ready? Number 5. All right, we have to find the summation, okay, from 1 to 12, so the first 12 terms, and this is our formula. Okay, so let's go plug it in. If I put in a 1, 1 minus 0, or 1 minus 1 is 0. If I put in a 2, 2 minus 1 is 1. Let's put in a 3. 4. Most of the time, you start to see that pattern and you can just kind of go with it. And so you can do that. What you need to be careful about is where to stop. So when is the 12th term? Okay. And the 12th term for this one is actually going to have us stop at 11. Now, 2 things really quickly. If you're getting your calculator, put it down, okay? Because we're going to work smarter, not harder. The second thing I wanted to tell you, if it says expand the series, it means to write this out. If it says evaluate, that means actually do the math and get the answer, okay? Here's why I wanted you to put your calculator away. Ready? We're going to work smarter, not harder. 11 plus 0 is 11. 10 and 1 is 11. 9 and 2 is 11. 8 and 3, 7 and 4, 6 and 5. There's a total of 6 of them, so this answer is 66. Okay, work smarter, not harder. Okay, all right, let's do it again. Ready? Summation notation. N equals 1, we're going to go to 7. So if I put in a 1, I get -3. If I put in a 2, -6, 3, 4, 5, 6, 7. Okay, and if you add all of that up, you get a -84. Okay, last little detail that I want to share, then you're going to go try some of these on your own. All right, so your job is to kind of finish up all of the problems that we haven't done, besides the ones that we crossed out, okay? But number 7 should be good. Number 8 is a little bit different. So notice how number 8 has a 2. This is the term number you're going to start with. So you're going to plug in a 2, and then you're going to plug in a 3, 4, 5, 6, 7, 8, and you're going to stop at the 9. Okay, so you're starting with the second term and you're ending with the 9th term. Same thing when you get down to number 10, number 11, number 12. You're going to start with the 4th term and end with the 8th term. All right, so I want you to be on the lookout for another video on how to get some extra help on some of those more tough problems down at the bottom. And send me an email if you need any help. I'll see you guys later. Have fun with this new math.